Lesson 2.5, domain, range, and intervals of increase and decrease. So first of all, before we get into that, we need to learn about set notation and interval notation. Now, set notation is written with inequalities. So if I were to express x is greater than or equal to 2 on like a number line, right? So at 2, I would have a bubble. I would color it in because we're going to count the 2 because we have the equal to right here, right? So x is greater than or equal to. So we're counting the 2. Now greater than 2, if x is greater than 2, that's to the right. So that means that we'd be moving this way, right, to the right forever. Right? Now the way we express this in interval notation, right? So interval notation, all right, we use these brackets and these parentheses and then some numbers. So first you need to understand that this number right here, whatever this value is, it's how far the farthest to the left. Just think of it as farthest to the left. Farthest left. This value right here, whatever it is farthest right. Okay, farthest right. And then if you have a parentheses, that means you don't include the value. The value. Now, infinity, obviously infinity is a concept, it's not even a number, so we cannot include infinity, right? Because it keeps on going forever. So that's why whenever you have infinity, it's always going to be a parentheses. But let's say there was a number here. Let's say there's like the number was, let's say 12, and you don't want to include 12, then you would put a parentheses instead of a bracket. So parentheses means we don't include that number. Now, whenever you use infinity or negative infinity, you will always put a parentheses next to it. Now, the bracket means you include the number. Okay, that means we count the 2. You notice over here, we colored in the 2, the bubble by the 2, because we're going to count the 2. So that's why over here, we next to the 2, we put a bracket, because the bracket means it tells us we're going to count this number, whatever it is. Okay, so in interval notation, this first value, all right, is, think of it as farthest to the left. Okay, well, farthest to the left, all right, on this number line here is 2, and we want to count the 2. That's why we have a bracket, all right, next to it. And then going from left to right, right? So farthest from the left, and as we move to the right, well, we're going to the right forever. So if we're going to the right forever, that's positive infinity. So we have positive infinity here, and we have a parentheses, right? Because you cannot count infinity, right? You cannot include infinity. So whenever you're using infinity or negative infinity, it's always going to be a parentheses next to it, okay? So let's do the next one. Erase this real quick. X less than 4. So let's say right here, here's 4, but we're not going to count the 4, so we have an open bubble, right? And then x less than 4, so we're moving to the left, right? Like that. So in interval notation, right, remember we start left to right. So coming from the left, right, from the left here, we're going left forever. So that's why we have negative infinity here. And remember I told you, every time you use infinity or negative infinity, it's always going to be a parentheses next to it. Now farthest to the right, the farthest to the right we go is 4. So we have 4 right here. And then since we don't include the 4, we have another parentheses. Okay? Let's try another one. So we have from negative 1 to 6. Okay? And at negative 1, we don't include, so open bubble. At 6, we do include, close bubble, color it in. And then x is in between, okay? So in between is going to be in between these values. So in interval notation, starting from left to right, so the farthest left is negative 1, right? The farthest left is negative 1, and we don't include it. So we have negative 1 and a parentheses telling us we don't include the negative 1. The farthest to the right we go is positive 6, and we do include it, so we have a positive 6, and we have a bracket telling us we do include the 6. Okay. Now let's say you have y. So up here, our example was with x, right? So if you have y, think of the y-axis, right? So think of this as the y-axis now. This is like the y-axis. So if y is greater than 8, so think of greater than 8. So the y-axis moves up and down. So if this is positive 8 right here, and we're not including it, so open bubble. So if y is greater than 8, that means that it would be going up, right? We're going to go up this way. Now, when it's y instead of x, this value here, instead of farthest left, farthest right, this is going to be the pretty much the lowest, and this value here is going to represent the highest. Right? So the lowest this graph goes is positive 8, and we don't include it, so we have a parentheses. Now the highest it goes, well, it goes up forever, so that's positive infinity. And then we have a parentheses because it's infinity. Okay, so interval notation, remember if the variable is x, it moves left and right. If the variable is y, right? If your variable here is y, then interval notation is going to move, right? Basically the lowest to the highest, or the bottom to the top. Okay. Let's take a look at over here, -5. Let's say we have -5 right here. There's a -5, and we do include it. Okay. So we have a colored in bubble. If y is less than -5, if it's less than -5, it's going to move down. Okay. So in interval notation, now you have to remember we start from the bottom, right, and we go up. Okay. We start from the bottom and we go up, from the lowest to the highest, right? So the lowest this graph goes, it goes down forever. So that's why we have right here negative infinity, because it goes down forever right here. Then we have a parentheses because it's infinity. So negative infinity, we have parentheses. Then it goes up. What's the highest it goes up to? The highest it goes up to is -5, and we want to include it. So we have -5, right, in a bracket. Okay. So that's how we express if you have like a visual graph like this, like number lines, right? X and Y axis. That's how we express it in interval notation. Okay. So I'll show a couple more examples just to make sure you guys get it. So if x is less than or equal to 5, right? So I've got 5 here, less than or equal to. So I'm going to include the 5. Right? If it's less than or equal to 5, so the numbers less than 5 are going this way. So in interval notation, what that means is, so in interval notation, remember, start from the left. So we're going to the left forever, right? So that's going to be negative infinity. Now what's the farthest to the right the graph goes? Oh, +5, and we include the 5, so I put a bracket. Okay. Over here, x is less than 0, so I've got 0. If x is less than 0, we're going this way. And also, we don't include the 0, so we have an open bubble. So what's the think farthest to the left? Oh, the farthest to the left, the graph is going forever. So negative infinity again. And then farthest to the right is 0, and we don't include it. So another parentheses. Over here, x is greater than or equal to 4. So we have, let's say, +4. We're going to color in the bubble because we're including the 4. And then it's greater than 4. So it's going forever to the right. So the way we write this in interval notation, so the farthest to the left the graph goes, oh, that's 4. And we count the 4, so a bracket. And it goes to the right forever, so that goes infinity, parentheses. Okay. Between -2, x is between -2 and 2. All right, and we have 2 open bubbles. Like this. So in interval notation, so the farthest to the left, oh, that's -2, and we don't count it. The farthest to the right, oh, that's +2, and we don't count it. So parentheses. Okay. So I'll do one more. So let's say right here, we have between -1 and 0. and we're counting both, so 2 closed bubbles. So x is in between these two, okay? So in interval notation, this would be the farthest to the left is -1, right? And we count it, so it's a bracket. Farthest to the right is 0, and we count it, so it's a bracket, okay? All right, so let's take a look at domain and range, okay? To find the domain and range of a graph, basically the most important thing you need to remember is domain, we're always thinking of the x values, right? So the domain, we're always thinking of the x values. The range, we think of the y values, okay? So whenever you're trying to find the domain, you want to think from the left to the right, find all the values the graph covers. When you're trying to find the range, from the bottom to the top, find all the y values the graph covers. Okay, so let's take a look at what I mean by that. So we have this graph right here, right? This graph right here. So from the left to the right, you notice the farthest to the left the graph goes is -3 right here, right? -3. The farthest to the right the graph goes is 1, right? So the domain and the graph covers all these x values. So it covers all these x values right here, right? Now, when we're trying to find the domain, when we're trying to find the range, right, we go from bottom to top. So what's the lowest, right, this graph goes, right? So the lowest the graph goes is -4. And then what's the highest the graph goes? Right, the highest the graph goes is 0. Okay? So that's how you find the domain and range. You think of, so domain, what's the farthest to the left and the farthest to the right the graph goes, right? And you notice this graph covers all these x values, right? Then for the range, right? For the range, what's the lowest the graph goes? What's the highest the graph goes? And then you notice that this graph is going to cover, right, all these y values right here, right? It covers all these y values right here. The lowest it goes is -4, the highest it goes is 0, right? And it covers all the y values in between. Okay, so that's the idea of how you find the domain and range. And then you would express your answers in interval notation. Okay, and we'll do examples in a moment so you see. Now let's talk about intervals of increase or decrease. Okay, so first of all, the most important thing is whenever you're trying to find intervals, right, intervals of increase or decrease, okay, you always read the graph from left to right, okay? So from left to right here, this is increasing, it's going up, okay? Because if you don't read it from left to right, if you go right to left, it would be decreasing, right? So make sure you read the graph, always read the graph from going from left to the right, okay? So from left to right here, this would also be considered increasing. Now from left to right, over here, this would be considered decreasing because it's going down, okay? So just remember intervals of increase or decrease, we always go from left to right. We read the graph from left to right, okay? Okay, so let's put this whole lesson together here, right? So we have this parabola right here. So first, let's find all the things that we are already familiar with, right? Like we know what the vertex is. The vertex is right here, right? So the coordinates are 3, -3. The axis of symmetry, right? The axis of symmetry is going to go through the x value of the vertex. We know this is going to be x equals 3. That's the equation. Domain and range we'll get to in a moment. Intervals of increase, decrease, we'll get to it in a moment. Minimum or maximum value. Well, the vertex is the highest, so we know we're going to have a max, and that number is -3, right? Which is the y value of the vertex. So this is all old information. Now, so domain. So let's talk about domain here. Now, the one thing you have to remember about a parabola, remember it keeps on getting wider, right? If this parabola keeps on going down, right, it's going to keep on getting wider and wider and wider. So what's the farthest to the left that this graph goes? What's the farthest to the left that this graph goes? Well, it's going to keep on going, to the left forever. What's the farthest to the right this graph goes? It's going to keep on going to the right forever because it's going to keep on getting wider on both sides, right? So that means that our domain, right, is going to keep on going to the left forever, so that's -infinity. it's going to keep on going to the right forever, so that would be positive infinity. And remember, infinity in interval notation, we use the parentheses, right? Because you cannot include infinity, right? You can't count that value. Right? Infinity is not a value, it's a concept. Okay? Now the range. Well, the range is, what's the lowest the graph goes? Well, the graph goes down forever. What's the highest it goes? The highest it goes to is 3 right here, right? So now just be careful when you write it. For interval notation, we have to go from the bottom to the top. So the first value here represents the bottom. We're going down forever. That's negative infinity. And then the highest we get to is negative 3. And we do include the negative 3, so then we put a bracket there. Okay, so that's how you find the domain and range of a quadratic or a parabola. Now, intervals of increase and decrease. So you notice the graph is going to be increasing. Okay, let me erase this right here. So you notice the graph is going to be increasing from, basically it's going up, right? It's going to be increasing when it gets right there, okay? So what are the intervals of increasing, right? So coming from the left to the right, because remember we always go from left to right. So coming from the left, remember this graph goes down to the bottom forever. So intervals are increasing. So from the left, it's coming from negative infinity, right? And then it gets to right here, right? Which is 3, 3. And then we would put a parentheses around the 3, okay? Because right at 3 it's neither increasing or decreasing anymore, right? So intervals of increase and decrease, you're always going to put these parentheses, okay? So there's always going to be parentheses for intervals of increase and decrease. So that's something you want to make a note of. So when is the graph increasing, right? Well, all these x values, right? So you notice, if you think of what we just did, if this goes down forever, it's going to cover all these x's, right? And then it's increasing, 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 and then right here, at 3, it's not increasing or decreasing anymore. When it gets to the vertex, it just stops, right? So at 3 is where it stops to increase. So that's why we have 3 here, but we don't include the 3 because it stops at 3. When it stops, it's not increasing anymore, it stopped. Okay. Now intervals of decrease. Well, when is it decreasing? I'll do the decreasing in, let's say, blue. So now it starts decreasing. Oops, blue. It starts decreasing over here this way. So what are the x values, right? Where it's decreasing. So it's decreasing after 3 over here, right? It's decreasing after 3. All these x values right here. And it goes down forever. So from the left, all right, so from the farthest left, right, the interval of decrease, well, it starts decreasing at 3. We put a parentheses. And then what's the farthest to the right it goes? It goes infinity, right? It covers all these x values because it keeps on getting wider, the parabola. Positive infinity. And then we have another parentheses. Okay? So something you really want to make a note of, intervals of increase and decrease, intervals of increase and decrease, always use parentheses. All right, so you're not going to have any brackets for intervals of increase or decrease. Okay? Let's take a look at another example. So at the beginning, I know this is kind of weird. After a few examples, I think you guys get the hang of it. So number 2 here. All right, first I'll find my vertex. So my vertex is 1, 4. Axis of symmetry is going to be x equals 1. So I'm going to have a minimum, and the value is 4. Right? Now let's find my domain. Right? So domain, what's the farthest to the left and right this graph goes? So remember the parabolic, it gets wider, right, on both sides. So if it gets wider on both sides, that means it's going to cover, right, all the x values, left and right. So once again, the domain is going to be negative infinity, right? The farthest to the left it goes is negative infinity, right? Because it doesn't go to the left forever. Negative infinity. Farthest to the right is positive infinity. What about the range? What's the lowest to the highest it goes? Well, the lowest the graph goes is right here at 4. Then the highest it goes, well, it goes up forever. Okay, so when we write this, remember the first value is the lowest, so the lowest is 4, right? And we count the 4. And the highest it goes, well, it goes up forever, so positive infinity. And we have your bracket. Okay, so remember domain and range, right? You might use the bracket. Okay, it's intervals of increase and decrease where you will never use the bracket, right? So that's domain and range. Erase this. Now let's talk about intervals of increase and decrease. So when is the graph increasing? The graph is increasing this part right here, right? It's going up. Right? So look at the x values where the graph is increasing. These are the x values where the graph is increasing, right? So the way we write this, well, from 1, the graph is increasing. Remember, intervals of increase, decrease, we always use parentheses only. So 1, right, going to positive infinity, right? And when is the graph decreasing? The graph is decreasing, right? It's going down, right? And what are the x values where it's decreasing? It's decreasing from here, right? So coming from the left right here, right? So we have intervals of decrease. So from the left is coming from the left right here, negative infinity. Then it's decreasing, 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 and then it stops right here where the x is 1, right? Remember, we're focused. We're not worried about. We're not looking at the y values. We're looking at the x values right now. At x equals 1, that's where the vertex is, and then it stops, right? So then at 1 there, it's no longer decreasing. It stops. So we have a parentheses. Okay. Let's try one more. So we've got right here, vertex is 3, 2. Axis of symmetry, x equals 3. We're going to have a maximum, and the maximum is the same as the y value of the vertex, which is 2. Right. Now, let's talk about domain. So the domain, remember a parabola, it gets wider because it goes on forever. So if it goes on forever, that means that it's going to cover the x-axis, right? It's going to cover the x-axis forever. So going farthest to the left, well, it's going to keep on getting wider to the left. So the domain is negative infinity. What about to the right? It keeps on getting wider to the right, positive infinity. And then the range, right? What's the lowest it goes and what's the highest it goes? Well, the lowest it goes, well, it goes forever, right? It goes forever to the bottom. And then the highest it gets to, though, the highest it gets to is 2. Okay? So the way we write the range, well, what's the lowest it goes? Because the first value represents the lowest. Well, negative infinity, it goes down forever. But the highest it gets to is positive 2, and we do count it, so we put a bracket. Now let's take a look at intervals of increase and decrease. So when is the graph increasing? The graph is increasing right here, right? That's when the graph is increasing. Now, what are the x values that covers this part? Well, these are the x values, right, where the graph is increasing. So coming from left to right, so from left to right, we have negative infinity, right? And then we get to 3, right? The graph is increasing. We get to 3 on the x, and the graph is no longer increasing. Okay, it just stops at the vertex. So we have a parentheses there. Now, for decreasing, when is the graph decreasing? The graph is decreasing when we have this part right here. The graph is decreasing now. So what are the x values where the graph is decreasing? The graph is decreasing, right? All these x values right here. Now it goes down forever, so it's going to keep on going to the right forever. So when you express this, intervals of decrease, so what are the x values? where the graph is, all right, decreasing. So the farthest left is 3, right? And the farthest to the right is positive infinity. Okay?